All right, here's our video, our third video in pre-calculus. We're modeling composite functions. In the last video, we did some composite functions. So go back to the other video if you're not sure about composite functions, but just in generally we're just taking two functions and putting them together. So we'll do a little example with that here. So let's get a clean page first of all. All right, so let's say when you're having them, we want to model them. We want to have, let's say, the input we're going to use and the output, right? So this is the domain or the x, that's the range, or the y, but we use like f of x, for example. And we have this domain and range box. And so let's say we use an example of, let's say, gallons or hours or miles. We can use functions like that. So let's say that we're traveling around the city. Maybe we're in Brooklyn. It's hard to drive in Brooklyn. So let's say we're going to use an input of, say, hours. And the more hours we drive, the more miles we'll get, right? So that makes sense, right? So hours and miles make sense that hours is independent. The independent variable is hours. So let's say we used f of x, we found an equation, and let's say we just said 6x plus 20. So this will be if we're driving around the city, and the x is going to represent the hours. So the number of hours that we drive will give us f of x, which will be the miles. So this is a function of hours to miles, as we see here. Now, for example, let's say we went 5 hours. What do we do? If we drove for 5 hours without stopping and not going around in a circle, we're just saying we're just driving straight for some reason, who knows why. Or even if we're going in a circle, so the miles will accumulate in the car, right? The car is going to show the number of miles you went, even if you went in a circle. So we just plug in 5 with the x right there, and we're going to have 30 plus 20, and we know we'll go 50 miles. So if we go 5 hours driving in the car, you'll go 50 miles in this particular place in the world. So that's one equation. So what if we made another equation? We'll change the color. All right, and this time we're going to make miles the input. So if we made miles the input on the next equation, what will be the output? What do you think we could use? Well, the more miles you go, we know the more gas you will spend. The more money you'll spend on gas. So we can say miles, and we can then say that the output will be money spent on gas. So you see on these composite functions, you can take one which was the output, and then you can make it the input. And you can do vice versa. One with the input then can become the output. So what equation can we get here? Let's say now we had f of x, so we're going to use g of x. And we'll say g of x equals, let's say, 0.17x. Now in this case, we're saying the x is the miles. The more miles you go, the more money you'll spend on gas. So this is saying 17 cents a mile, right? And so what we want to do is we want to take these two functions and put them together. That's what a composite function is. And by the way, if we take the last equation we used, we went 50 miles, just wandering around Brooklyn. And so if we plug in 50 here, we went 50 miles at 17 cents per gallon, then we know that g of x would equal $8.50. So when we take these two equations and we put them together, we should get these values. So let's put those two equations together. So again, let's clean this out, review it, clear it out here, change the color. So on one, we had f of x. We said f of x was 6x plus 20. And then again, if we plugged in a 5, 5 hours, the x here represented hours. And then we had another equation, g of x, and we said it was 0.17x. And in this case, the x here represented miles. And we wanted to put them together. So when you put them together, it's a composite function. Now, let's say you want to know how much money you will spend based on where you went in Brooklyn or whatever city you were in. So if we want to find out how much money we spent, we're going to want to know what g of x is to f of x. So we want to say g and have this little circle here from the last video, if you remember. G, and that O just means it's a composite function. So we're basically saying g of f of x. G of f of x. So let's just plug it in. So we know that g is 0.17, and then we want to throw in what f of x is. And f of x is 6x plus 20. And we'll just distribute that. So when you distribute that, you're going to have 1.02x plus 34. So again, the reason we started with g is because we want to know how much money we will spend based on traveling around with that function, 6x plus 20. That's why we put g first. Now remember, when we did this the first time, with this one, we plugged in, we said we went 5 hours. We got 50 miles. And over here, when we said 50 miles, we got $8.50. So this equation here, this function that we combined, should give us $8.50. Let's see if it does. So what do we put in for x? What do you think we have to put in for x? So let's make sure we understand it. The first one, we want to know how many hours gave us miles. So this was f of x over here was how many miles to hours. And over here with g of x was how many miles to money. Now we want to know how much hours to money. You get it? So all we have to do is put in the hours, plug in 5. Plug in the 5 right there. And when you plug that in, you'll get $8.50. So again, we're just taking two functions, putting them together. And in this case, in this video, we modeled two functions and we put them together. That's why it's called a composite function. All right, that's our video today.